Hi, AP Chemistry. So we are continuing with the basics of bonding, and in this video, we want to look at sigma and pi bonding. All right, some new terms, but it's a very simple concept. So all covalent bonds have to do with orbital overlap, right? We see this here, whether it is the unhybridized s orbital of hydrogen or an sp3 hybridized orbital of chlorine. What has to happen is those orbitals have to overlap, right? We see the two s's overlap here. We see the s and the hybrid orbital overlap here. We see two hybrid orbitals overlap here, right? All of the bonding is that orbital overlap. All right, so we have two terms. Whenever an s orbital is overlapping, we call it a sigma bond, right? So hydrogen has those unhybridized s orbitals. Here we see a very simple sigma bond, all right? And any s orbital counts. So all of those hybrid orbitals are going to count. The sp, the sp2, the sp3, the sp3d, the sp3d2. All of those have some s characteristic. As long as it has any s characteristic, we are going to call it a sigma bond. So here we see carbon with its 4 hybridized sp3 orbitals, and each one is overlapping with a hydrogen to make methane. All right, and so we see 4 sigma bonds. Each covalent bond is designated a sigma bond, right? It gives us that tetrahedral shape, the 109.5 degree bond angle, right? That is our methane molecule, all right? When we look at ethane, all right, the carbon-carbon bond is a sigma bond, right? Because that bond is occurring in the sp3 hybridized orbitals, right? So we're getting s overlap. It doesn't matter that it's hybridized. It has some s characteristic, so it counts as a sigma bond, and this is the Greek symbol for sigma. All right, so when we look, the easy way to remember this, all single bonds are sigma bonds. Single bond, sigma bond, right? They can be thought of synonymously. All right, so now what about the double and the triple bonds, right? Multi-bonds, we'll say. In a double bond, one of the bonds is a sigma bond, the other is a pi bond. And yes, we will use the pi symbol like used in math class, all right? So anytime you see a double bond, it's one sigma bond and one pi bond, all right? A triple bond is gonna be one sigma and 2 pi bonds, right? The top and the bottom we could think of as the pi bond. You don't have to worry about the order, all right? But a triple bond, 1 sigma, 2 pi bonds, all right? A pi bond is when an unhybridized p orbital overlaps, right? And because the p orbital has that dumbbell shape, we end up getting the p orbital kind of reaching over and below. So the middle is the axis plane that the sigma bond is occurring, and the pi bond is occurring above and below it. It's kind of weird. It's like you got an L train and a subway, but this is a pi bond. It is p orbitals overlapping, right? So sigma bonds, s orbitals, pi bonds, p orbitals, and they have slightly different shapes, right? So the sigma bond is in the middle, and the pi bond is happening above and below it, and it's kind of weird, right? It's kind of hard to visualize, but this is what we're looking at. All you need to know, right? All you need to know is if there's a single bond, it's a sigma bond. If there's a double bond, it's 1 sigma, 1 pi. If it's a triple bond, it is 1 sigma and 2 pi bonds. All right, so when we look at some organic structures, right, we should be able to count the number of bonds, right? So we see 4 single bonds. Those are all sigma bonds. Right? In the double bond, 1 sigma, 1 pi, and in the triple bond, 1 sigma, 2 pi. This gives us a total of 6 total sigma bonds and 3 pi bonds occurring. All right? In a benzene structure, right? All of those carbon-hydrogen bonds are single bonds, and we see 3 carbon-carbon single bonds, and there's 3 double bonds, so 3 sigma and 3 pi, for a total of 12 sigma bonds and 3 pi bonds, all right? We can see all different kinds of funky structures. Here, we can see the multi-bonds first. We see that there's gonna be a pi bond in that N-N bond, because it's a double bond. There's gonna be 2 pi bonds in the carbon-carbon triple bond, all right? Then we're gonna have the rest sigma bonds. All the single bonds are sigma bonds, and the double and triple bond each have 1 sigma bond, right? So here we would get a total of 8 sigma and 3 pi. So again, these are designations. Sigma for the s orbitals, and that includes hybridized s orbitals, and pi for the p orbitals, which are unhybridized. And the simple way to remember, all of the single bonds are sigma bonds, and all of the multi-bonds always include 1 sigma, and the rest are pi, right? So a double bond, 1 sigma, 1 pi. A triple bond, 1 sigma, 2 pi. All right, so that is it for our S or sigma and pi bonding theory.